Picture this, a $78,910 Tesla super electric plane. Designed to redefine modern aviation, is no longer a distant dream. It's set to become reality in 2026, hidden behind Tesla's familiar veil of secrecy and innovation. The company's engineers have been working on a master plan. It's about to shake the very foundations of the aviation industry. Whether you live in New York, London, Sydney, or Los Angeles, the real question isn't if Tesla will take to the skies, but when you and your family will be flying in one of these revolutionary electric jets. So buckle up, because the next era of Tesla's expansion, from the ground to the sky, is officially on the horizon. Tesla's next major leap starts where its dominance began, inside its Gigafactories. These vast production hubs, which have powered Tesla's electric car empire, are now being transformed to give birth to the company's first fleet of electric aircraft. The plan is bold. Electric plane production begins in the second quarter of 2026. Spearheaded by three of Tesla's biggest and most advanced sites, Gigafactory Texas in Austin, Gigafactory Shanghai in China, and Gigafactory Berlin-Brandenburg in Germany. Not long after, in early 2027, Gigafactory Mexico in Monterrey will join the lineup, expanding Tesla's aerial production capabilities across the Americas. The locations weren't chosen by chance. Each Gigafactory represents a regional hub for a global strategy. Texas, which produced more than 410,000 vehicles in the second quarter of 2025 alone, has proven its ability to handle large-scale manufacturing with precision and speed. Shanghai anchors the rapidly expanding Asia-Pacific market. Berlin serves the European and UK markets, and Mexico connects North and Latin America. Together, they form what Tesla calls its global aviation production triangle, a coordinated, worldwide manufacturing system designed to dominate the skies by 2030. By 2026, Tesla will dedicate roughly 20% of the total floor space at each of these Gigafactories specifically for aircraft production. Automotive lines are being retrofitted with aerospace-grade technologies capable of producing composite airframes and housing next-generation lithium-aluminum air battery modules. Backing this transformation is a $1.5 billion investment across the three main sites, a figure that reflects both Tesla's ambition and its history of fast, efficient factory builds. To put that speed into perspective, the Shanghai Gigafactory was built in just 10 months back in 2019. So while some may think producing electric aircraft at scale is a stretch, Tesla's track record suggests it's entirely achievable. Gigafactory Texas is expected to become the heart of global production, assembling around 5,000 electric planes per year by 2028, nearly half of Tesla's total projected annual output. Shanghai will follow, with an estimated 3,000 planes yearly, Berlin with 2,000, and Mexico another 2,000 by 2027. That's 10,000 aircraft per year by 2028 and up to 20,000 annually by 2030. To put those numbers in context, the global light aircraft market currently sells around 200,000 units per year, so Tesla is targeting a 5% market share within just 4 years of launch. What gives Tesla the edge to achieve that? Automation. Over 80% of Tesla's current vehicle assembly process is robot-operated. It's giving it a 30% cost advantage in labor efficiency over traditional aerospace giants like Boeing or Airbus. On top of that, Tesla's partnership with SpaceX brings aerospace-grade expertise in lightweight composite materials, aerodynamic modeling, and FAA certifications. These advantages allow Tesla to reduce its overall production costs by roughly 20% compared to industry norms. Each Gigafactory will also produce around 10 gigawatts of aluminum air batteries every year, enough to power thousands of electric planes. This production capacity echoes the same rapid scaling Tesla achieved in the automotive world, where the company grew from producing 936,000 cars in 2021 to nearly 1.8 million by 2024. Now, Tesla is applying that same momentum to the skies. On the distribution side, Tesla's strategy is just as innovative. The company already operates more than 200 distribution centers across the globe for its vehicles and energy products, and it plans to repurpose many of these for electric plane deliveries. Managing a few thousand aircraft per year will be easy for a company that delivered over 1.7 million cars in 2024 alone. But Tesla isn't stopping there. It's reimagining how people will receive and operate their aircraft. The company plans to construct 100 urban vertiports by 2028. 50 of these will be built across the US, 30 in Europe, 15 in Asia, and 5 across the UK and Australia. These vertiports won't just be landing pads. They'll double as high-speed charging stations, maintenance hubs, and local delivery centers for Tesla planes. Imagine being able to pick up or charge your electric jet right in your city in Los Angeles, New York, or Las Vegas instead of traveling hours to a major airport. That kind of urban integration is Tesla's answer to one of aviation's oldest challenges. Accessibility. Order and delivery timelines reflect Tesla's trademark speed. Customers in the U.S. who place orders by the third quarter of 2026 can expect to receive their planes by the end of that same year. In Europe, the UK, and Asia, deliveries will follow similar schedules. Powered by Tesla's global Gigafactory output and synchronized logistics network, at the core of this entire breakthrough lies Tesla's Aluminaire battery, the key technology that finally makes electric flight practical. For decades, battery weight has been the main obstacle to electric aviation. Traditional lithium-ion batteries are powerful but heavy, and that weight drastically limits flight range. Tesla's new Aluminaire technology changes everything. This battery chemistry delivers an impressive 520 watt-hours per kilogram, about 38%. Higher than the energy density of standard lithium-ion cells. For small aircraft, this means reducing total battery weight by over 3,000 pounds, unlocking performance levels that were previously unattainable. Aluminaire batteries achieve this by drawing oxygen from the atmosphere to serve as the cathode, eliminating the need to carry that component internally. The result is a significantly lighter and more energy-dense system without compromising safety or range. In lab testing, Tesla has achieved experimental results as high as 1,000 watt-hours per kilogram, while 520 watt-hours per kilogram has already been certified for aviation use. While jet fuel still contains far more raw energy, about 12,000 watt-hours per kilogram, Tesla's electric motors are roughly 3 times more efficient than conventional jet engines, allowing the new battery to achieve ranges of up to 720 miles per charge. That's enough to cover most common U.S. domestic routes like New York to Chicago or Los Angeles to Denver, all with zero emissions, minimal noise, and a fraction of the operating cost. Safety. A cornerstone of Tesla's engineering philosophy is another major advantage. Aluminaire batteries are completely non-flammable and fully compliant with FAA and European Space Agency aviation standards. Unlike lithium-ion packs, they don't suffer from thermal runaway issues, making them far safer for flight applications. With an expected lifespan of around 3,000 charge cycles equivalent to roughly 30 years if flown 100 times per year, these batteries are built for durability and long-term reliability. Adding to that, Tesla will leverage SpaceX's experience with composite materials, flight control systems, and autonomous navigation. The aircraft will be equipped with advanced AI-assisted piloting, enabling precision maneuvers, optimized flight paths, and predictive maintenance. Real-time diagnostics and onboard safety monitoring will ensure that the aircraft continuously self-assesses performance, effectively reducing the risk of mechanical failure to near zero. Tesla isn't just thinking about the planes, it's also building the ecosystem around them. The company has committed over $2 billion to develop a global network of ultra-fast charging and maintenance infrastructure specifically for its electric aircraft. There will be 100 high-capacity, 200-megawatt charging stations in the US, 50 in Europe, 40 in Asia, and 10 across the UK and Australia. These chargers, adapted from Tesla's semi-truck technology, will be capable of bringing a plane's battery to 80% capacity in just 30 to 45 minutes. Maintenance is also being redefined. Tesla plans to establish 50 specialized maintenance hubs around the world by 2028, strategically located near major gigafactories and Vertiports. Each of these facilities will use AI-powered diagnostic tools to identify and repair issues faster and more accurately than human technicians. The system is designed to reduce maintenance costs by 20% and guarantee a 24-hour turnaround for most repairs, a level of speed and efficiency unheard of in aviation. Every Tesla aircraft will be connected to SpaceX's global Starlink satellite network, allowing for seamless real-time communication, navigation, and over-the-air software updates anywhere in the world. This means each plane will operate with a 99.9% uptime rate, constantly monitored and optimized through satellite data. The result is a fleet of aircraft that essentially maintain and improve themselves over time, just like Tesla's cars do with their software updates. By merging Tesla's electric expertise, SpaceX's aerospace innovation, and Starlink's satellite connectivity, Elon Musk is building something far greater than just an electric plane. He's creating a self-sustaining ecosystem that merges the convenience of electric mobility with the freedom of flight. A system where personal aviation is not just for the elite, but for the everyday traveler, where charging stations,